In this lesson, we will look at vertical asymptotes and holes in the graphs of rational functions. Let's start with the definition. The line x equals c is called a vertical asymptote of the graph of a function y equals f of x if as x approaches c from the left or as x approaches c from the right, either f of x approaches infinity or f of x approaches negative infinity. Let's look at a graph of a function f of x, and notice we have a vertical asymptote at x equals 2. The vertical asymptote is x equals 2. As x approaches 2 from the left, f of x approaches negative infinity, and as x approaches 2 from the right, f of x approaches positive infinity. So we would say that x equals 2 is a vertical asymptote here. Let's find some vertical asymptotes. First, of the function g of x equals x squared minus x minus 2 over x squared plus x minus 2. To find a vertical asymptote, we'll begin by factoring g of x. Here we have x minus 2 times x plus 1 over x plus 2 times x minus 1. We look to see if there are any like factors in the numerator and denominator that we can eliminate. There are none here. So we will go ahead and look at our denominator. Our vertical asymptotes occur at x values in the denominator, which cause the denominator to be equal to 0. And so I will set x plus 2 equal to 0 and x minus 1 equal to 0 to find my vertical asymptotes. I have a vertical asymptote, the line x equals negative 2, and a vertical asymptote, the line x equals 1. If we look at a graph of the function, we can see at x equals negative 2 and at x equals 1, it does appear that we have vertical asymptotes. Next, we'll find the vertical asymptote or asymptotes of r of x equals 2x plus 2 over x squared plus 4x plus 3. I'll begin by factoring. So in the numerator, I have 2 times x plus 1. In the denominator, x plus 3 times x plus 1. We do have x plus 1 as a factor in both the numerator and denominator here, so I will eliminate that. And I will rewrite r of x as equal to 2 over x plus 3, but I want to make a note that x cannot be equal to negative 1. And so our vertical asymptote is going to be the value of x, which causes x plus 3 to be equal to 0. So we have a vertical asymptote, the line x equals negative 3, and I also have a hole in my graph at the point x equals negative 1. The graph, as you can see, has a vertical asymptote at x equals negative 3, and there is a hole in the graph when x is equal to negative 1. Try on your own, find the vertical asymptotes of the rational function h of x equals negative 3x squared plus 12x minus 11 over x squared minus 4x plus 4.